Alright, so here's our lesson on parallel and perpendicular lines. Starting out again, reviewing the idea that parallel lines... So anyway, parallel lines, two lines in the same plane that have the exact same slope. It's pretty easy to write an equation of a parallel line. Here we have a line that passes through 12,5 and is parallel to this one. So again, the key to being parallel is that they have the same slope. In other words, I'm going to write a line that reuses this slope that goes through this point. You're going to find point slope form to be one of your best friends here. So again, identify the slope first. The slope in here is 2/3. Then we're going to write an equation in point slope form. That's down here. So using this point, 12,5, notice the 12 goes here, the 5 goes here. We're using this slope. And I said I wanted that in slope-intercept form. So a little bit of translating fun here. You're going to take this, some algebra magic, and turn it into slope-intercept form. So now I have two lines, this one and this one, that are parallel because they have the same slope. Each go through different points though. Alrighty, so we actually have to do the work here. So we have to take a look. We have to take this point, and I want to make a line that goes through that point that is parallel to this one. In other words, I need to reuse the slope. So again, we're going to reuse this slope here of 2, and we're going to make a line that goes through this point. So what that looks like, we're going to use the point slope form. Y plus 1, right, because it's a negative 1, equals 2 times x plus 3. Little distributive property fun here. Y plus 1 equals 2x plus 6. Well, now we gotta start making it look more. So what is it? We're looking for slope-intercept form, right? So we're gonna subtract the 1, y equals 2x plus 5. Oh, there we go. Lucky us, that's the right answer. Now in the quiz and test, I'm gonna ask you to tell me if two lines are parallel, perpendicular, or neither. Now remember, parallel means that they have the exact same slope. Perpendicular means they have the opposite reciprocal. So the opposite, so like this, if it were 4/5, perpendicular would be negative 5/4. If it's anything else besides those, it's neither. So if I give it to you in this form, right? This is not any of my forms. It's not standard form, not slope-intercept, not point slope form. This one is slope-intercept form. So in order to compare them, I'd put them both into slope-intercept forms. So rewrite the first one, right? And put it in slope-intercept form. And we take a look. The slope is negative 5/4. The slope of the other one was 4/5. Guess what? Because they don't have the same slope, right? They're not parallel. But they are opposite reciprocals. In other words, if you multiply them, you get -1. So we would say that these two lines are perpendicular. So again, to review that, put them in the same form. So in this case, put them both in a slope-intercept form. And I'll even write with a marker here, this one and this one, slope-intercept form. Look at their slopes. If they're opposite reciprocals, it makes them perpendicular. Okay, so here we have to determine if the slope, or if these two lines rather, for A, are parallel, perpendicular, or neither. This one's already in slope-intercept form, lucky us. The other one we need to translate into it, so let's do that. We have 4x minus 3y equals 9. So subtract the 4x, subtract the 4x. So I end up with 4x. I'm sorry, I need to erase that there. I end up with negative 3y equals negative 4x plus 9. Again, I'm shooting for slope-intercept form, so that's why I put the negative 4x in front. Divide off the negative 3. Divide off the negative 3. I get y equals positive 4/3 x minus 3. So we take a look at the slope here. Positive 4/3, positive 3/4. They're reciprocals, but they're not negative reciprocals. So this is neither. This one's neither. The other one, let's take a quick look over here. Already in slope-intercept form here, so we got to work on the other one. We have 6y equals negative 1x plus 6. Divide off the 6. Divide off the 6. Y is negative 1/6 x plus 1. And let's see, they have the exact same slope, negative 1/6. So these two lines are parallel. Now again, you got to watch yourself too. Make sure they have different y-intercepts. Otherwise, it'd be the same line, right? So in this case, they are parallel. They're not the exact same line. Okay, so just like we made a parallel line by using the same slope and a different point, and went through point slope form, we can do the same thing with make a perpendicular line. So if I give to you which equation represents a line that passes through 2, 4, and is perpendicular to this. Remember, if it's perpendicular, I'm going to need a different slope. I'm going to need the slope of -3/1. It's going to pass through this point. So we're going to use the exact same method, if you will. I'm going to plug them into my point slope form. So plug the 4 in here, the 2 in here, and I'm going to do some algebra fun and turn it into slope-intercept form. So this line right here is perpendicular to this one because they have opposite reciprocal slopes, and it goes through this point because that's the point I used in my point slope form. So in this case, the answer is D. Now, it should be noted I'm not going to always be as nice to you. This time I am giving you the line in slope-intercept form so you can see the slope. Sometimes I might give it to you in standard form or some other form making it more difficult, some random messed up form that makes it more difficult to find the slopes. You might have to find that first. Luckily, I don't have to here. So what we're looking for is a perpendicular to this one going through this point. So the slope here is 2x. So my perpendicular slope is -1/2. Sorry, slope is 2, not 2x. So we're going to use that whole point slope form. Y minus 8 equals -1/2 times the quantity x minus 1. So a little distributive property fun here. Y minus 8 equals -1/2, x plus 1/2, right? And we're going to go ahead and add our 8 to both sides, add 8. So we end up with y equals -1/2 x plus 8 and 1/2, or really if you'd rather, y equals -1/2 x plus 17/2. So again, perpendicular slope right here of -1/2, perpendicular to 2, going through this given point, looks like this. So apparently, if you're an architect, there's some real-life applications for this. It says an architect uses software to design the ceiling of a room. The architect needs to enter an equation that represents a new beam. The new beam will be perpendicular to the existing beam. So here's the existing beam. And so it's going to be perpendicular. And will pass through the corner represented by the blue dot. Guess what? That's another point over here. So basically make a beam that goes like this. So we need that equation. I'm willing to bet, by the way, in the real world, your software would just do that for you too, but we're not there. So again, we take this line right here, and we find its slope. And again, how do we do that? Well, we have a couple different points already given to us, right, along the way, and we can calculate the slope. And so the existing beam has a slope of -2/3. Again, I picked 2 points on that line to generate that. Find the opposite reciprocal, so I take that -2/3, flip it over, and I get 3/2. Use point slope form, and we're going to run through this point right here, which is 12/10. Plug it in. Algebra fun. We magically get this formula. So again, this line here is right there. Alrighty, so this time we're going to create another beam, kind of put beams everywhere, that goes to another corner, 0, 10, and is parallel, so it uses the same slope again. So what we're doing here, we take our y minus 10 equals -2/3 times x minus 0. So y minus 10 equals -2/3 x, right? We get rid of the 0 there. Add the 10, 10, y equals -2/3 x plus 10. And there you go.